So we're looking for factors of 1 that would add up to -2, so this is going to be -1 and -1. Okay, so if you're uncomfortable with how quickly I'm factoring, you can use AC method, remember, okay? But notice I'm equal to 0. So if I wanted to, I could rewrite this as something squared, okay? Or I could just say to myself, okay, I know I got to set x equal to 0, and I know I have to set x minus 1 equal to 0, but I don't need to do this one again because I already did it, right? But what's the multiplicity since it happens twice? 2. So the multiplicity is 2 here, which is even. So I'll go back to this one, but what does that mean about the graph then? Turns? Okay, so I end up getting x equals 1 for the x-intercept, right? And I know that the graph turns. What about this guy? If you look back up at plain old x, there was only how many of them? Only one of them, so the multiplicity of that one's just 1, which is odd. So what does that mean about the graph instead of turning? Crosses. And then last step before we can get to the graphing part is, does it have symmetry or not? So I'm going to scroll back up. Okay. Notice I have a odd power and an even power together, so what's that probably mean it's going to be then? Neither. In other words, all that tells you is you don't get a break. You don't get the benefit of knowing that it's the same on the left as it is on the right, so you're going to have to figure out what the graph looks like without that little bonus. Okay, so let's graph it and let's see what we know and what we maybe still need to know. So notice, if you go back up and look at the information we know, we're not going out that far. Like, we don't have points that are very big, right? So I'm just going to go out 2 in every direction, and I'm going to leave myself some space. So let's go through and plot the points I know. I know 0, 0 is the y-intercept. I know the x-intercepts are at 0 and 1. But I also know that the graph curves up to the right and what? Down to the left, right? So what's the only thing that I'm just not 100% sure about right now? Yeah, like what's happening in between there, right? But I actually know a little something more than I'm saying, right? I know that it crosses here, and I know that it turns here. Okay? So again, I'm going to use my dotted line here. I know that it goes through, but then I know that it has to come right back down again, right? So what's the only thing I don't really know? What's my question mark? Like, how far up does it go, right? That's our only thing you need to know, okay? So we just need to ask about or figure out what point then. If we want to know what's happening between 0 and 1, what would be a really good point to pick? 1/2 or 0.5, right? So I'm going to choose 1/2. You don't always have to choose fractions. It just so happens that the 2 that we looked at had a fraction right in the middle. Okay, so if I want to know the y, I just need to find f of 1/2, or if you rather, f of 0.5, either one. Your calculator can handle either, so we're going to plug that in. So 0.5 cubed minus 2 times 0.5 squared, and then plus 0.5. Okay, so your calculator will give this to you as 0.125. So what does that tell you about how far we go up? We got 0.125. Are we going up that far? No. Very, very little, right? In fact, I'm going to show you how very little it looks like when you actually look at it on the calculator. So I don't need to go up very far at all. I'm going to make it a little bit more obvious, but I just need to make kind of a little tiny peak there. I don't even need to go up to 1. Okay, so a couple of things that I want you to kind of keep in mind when you're doing these. Okay, you didn't know what you needed to pick for additional points until you did what? Like, these aren't cookie cutter problems. You're not going to be able to do the same thing every time, okay? Because you have to graph what you know to figure out what you don't know, right? You have to graph what you do know to figure out where your gaps in your graph are, okay? And the other thing is, I know that A lot of us love the graphing calculators. I do too. They're awesome, okay? But especially in a case like this, I think they're a little bit lacking. So I want to show you what the graph of this one looks like. And if you didn't know what you were looking for, I think you'd have a hard time knowing really what the details of this graph were. So x cubed, so you don't have to enter this in. You can just kind of look up here, minus 2x squared plus x. So notice that, like, if you graph it, I don't think I would have noticed that there was a little hump there. Like, I just would have thought it made a turn there and went back up. Like, I wouldn't know there was supposed to be a distinct little upward movement there, right? In fact, you'd only really know if you zoomed in. But if you didn't know to zoom in, you probably wouldn't see it at all, okay? So notice if you zoom in, it does show the little hump. But to see how small it is, even on the zoom, okay, it's just not very tall, right? And why isn't it very noticeable? Because it only goes up to what? 0.125. That's super, super small. Okay, so you're going to need to make sure you know the details. Use the calculator as your backup, but it is not the end all be all. Okay. All right, so I want to talk about the